So, hola, buenos dias. Good morning, everyone. My name is Nimisha Asthagiri. I'm an engineer and architect at edX. So right now I feel like, a mother who just has so much love to share and wants to smother their kids. Well, I just feel like there's so much knowledge I want to give to you guys, so, bear with me for the next half hour. Afterwards, I'm willing to also talk to you guys and the birds of feather at lunchtime as well, and we're also going to share the slides, so take what you can out of this. So I'm going to take you guys on a journey. We're going to look at it's a historical journey about edx-platform. We're going to look about how we got here, where are we now, what are our thoughts about where we'd like to go, and what are we actually doing right now to get there. So you guys all ready? Yes? Okay, here we go. So how are we involved? Well, here's one stop. You can look at the GitHub repo and what it has to say. December of 2011 was our first commit into the repo. And then there are different interpretations of this graph, possibly. One interpretation is that, okay, around 2013, wow, almost 300 commits in 1 week. There's a lot of activity going on. Well, if you have free online education for everyone, everywhere, and you have a mission, of course you're going to make so much activity. You have a small code base, right? And there's greenfield development. So there's a lot of activity going on. Eventually, though, it starts to taper off, as you can see. Well, your code base may have changed a little bit, and now you're thinking about more maintenance mode and incremental development. That's one interpretation of this graph. Let's look at what other data we have. If you look at the contributors to edx-platform, right, and in each time period, so that was definitely increasing linearly, and then, once again, it's starting to drop off. Now, mind you, this is just the edx-platform repo. We also have other repos in edx, but here's another view for us to consider. Then if you can look at team growth. Now this is only the engineers at edx itself. This doesn't include the awesome open source community that we have, but still this is the data I had at hand. So the team growth, right, from 2013 to 2017, steadily increasing. We're over 70 people now. So all these changes are happening within the team, within the code base. If you look at the code base a little bit closer, let's look at the number of files in the code base. That was linearly increasing, steadily increasing. Yeah, there was a little bit of a dip because we chose to pull out some language files, but as you can see, over time, that continues to increase. Maybe it's now plateauing. Once again, I said there are more additional repos. So let's take a little closer look at edx-platform. Well, small code base, thinking of a baby, it's just starting up to that December 2011. Later on, it starts to grow. And within the code base, we decide to split it up into LMS and Studio. Now, interesting thing about Conway's law, if you guys have heard of it, where like it or not, your code structure tends to mirror your organization structure. Well, you'll see that edx-platform is definitely no exception to this rule. So even at edx, we had an LMS team and a Studio team. Well, that's what you see in the code base. And then we also had Forums team that started in June of 2012. And we had another team working on Aura. And each of them had their own repos. I don't know if the resolution is that great, but they had edx Aura repo and this comment service repo. But then as engineering organizations, they grow and whatnot, of course reorganization happens, and let's see what happens to the code base along with it. So the engineering organization decides to reorg, and now we create a teaching and learning team. Teaching and learning team now owns all of edx-platform. There's LMS and Studio and Aura and Forums all within one team. But we're growing and we have demands and other features that we need to implement. So we add an analytics team coming and with their own repos. They don't want to deal with the edx-platform and the monolith that's growing. So definitely they want to be self-isolated and working on their own code base. Analytics team starts, the mobile team with their own open sourced repos, and the e-commerce team focusing more on the edx.org requirements, but e-commerce, course discovery, credentials, all other repos that are starting. So once again, you see that Conway's Law in action. And as you heard yesterday, Mark Hazeltine said yesterday morning, our CTO, that now we're going through another reorganization. Now we're actually being a lot more customer focused. We're going to have the educator team and the learner team and the business team. So what does this mean for our code base? What's going to happen? Well, we have that big monolith still that exists, the edx-platform, and there's educator components in it, and learner components, and business components, and all these teams now have to deal with that one single code base. And of course, they have their own repos in addition to it that are domain-specific to their own teams. But anyway, that's one look at this. We'll come back to this in a little while. And that was more talking about code. Let's look also at usage and how over time the usage of edx-platform has grown, at least specifically to edx.org. So now, where are we? This is the number of enrollments in thousands. So over 4 million enrollments per time period, steadily increasing over time. And then if you also look at compounded, how many total enrollments we have to date, we now have over 40 million enrollments on edx.org to date. So we need to scale along with this. If you look at data, by data I'm talking about number of courses on edx.org. The red line is talking about, once again, the compounded courses to date, and the blue line, the number of courses that are created at each timestamp, where we're now over 4,000 courses on edx.org. So we need to scale, and edx-platform is evolving this way as well. So that's how we've evolved to date. Where are we now? Once again, our beloved monolith comes back, and it's there. But what's going on in the inside? A lot of people, they've probably faced this as well in their own companies when they have a large code base, and there's a lot of tight coupling that exists. And definitely something that we need to deal with. There's a lot of interdependencies in the code base. And as a developer, when you want to make one change, well, now you have to make another change, and it's just a rippling effect, taking you from one place to another. Or you make a change, but then, you don't realize, but it actually breaks something else somewhere that you didn't even expect to. These are things that we deal with, both within edX and also outside in the community. If you want to make extensions and add features, these are things that are continuously blocking us at every pathway. We want to move fast. We can't, the learning community, all the requirements, there's so much that we want to do, but we are blocked and we're slowed down by our monolith. It started out simple, eventually became complex. And for good reasons, complex in a good way. Right? More features, more things that we need. We're working at it, we're doing our best. But what we want to make sure is that it does not become chaotic. High energy, unpredictable, these are things that are not what we want. So, what's a desirable future? What are we looking at? Well, let's take a look at what's going to make us happy. What's going to make us jump for joy? Well, all the things in orange that I have listed here, this is from the architect perspective, so don't get boiled down by all the terminology, but essentially the things I have in orange here are things that are great for deployment and for operational support. The things here in blue that I have here are more about scaling with the team size and scaling with the code base. So let's take a look closely at the orange things first. The reactive manifesto, which you guys can look up, I strongly encourage it. It talks about the orange things. It talks about being responsive. It talks about whenever an API is being requested, or whenever a user is requesting something, you want the system to respond as fast as it can. And what is the thing that you should be looking at? Not the average response rate, but the 99.9%. And why? Because when you're looking at scale, that that 1%, it's not 99.9, sorry, 99%. And why? Because when you're looking at that 1%, if you have 10 million learners in your system, there's 100,000 learners in that 1%. So 99 percentile is what is actually critical to look at. And at edx.org, we strive to make sure that those are all within less than 2-second response times. Yes, there are times where there might be exceptions, but that's the rule that we like to embrace. Resiliency. That's 99.9% uptime. And that's where our DevOps team works really hard in making sure that our systems are always up and available. And if your components are isolated, right, then if one fails, the other one doesn't necessarily fail. There's no domino effect. But resiliency is what we're aiming for. And elasticity. What do I mean by that? Well, if you want to horizontally scale your system, you want to think about which which components in your system can be scaled differently. On edx.org, the LMS has 13,000 requests per minute. But Studio, it has only 60 responses per minute, requests per minute, sorry. And so you want to scale them differently. So if you can isolate those components and make sure there are no common bottlenecks in between, then that's going to allow you to be elastic. Now, how are we going to get there? Well, let's take the reactive manifesto again. What it suggests is something called being message-driven or event-driven. And the reactive community is all around this. And so think about this. If you have one component, another component, if they're going to make a synchronous call, a blocking call, then if the other system is down, it's going to have a rippling effect. So if you have asynchronous, non-blocking calls, right, if you just send a message and let the other system know about it, wow, isn't all of a sudden your system more resilient, right? Isn't it going to allow you, therefore, to become more responsive and elasticity because there's now a lot more decoupling? So that's what we want to strive for. So now let me ask you guys, pop quiz, assessment. Everyone wake up. If you have an asynchronous system, is that going to be like an orchestra where you have a conductor that says, violins, cellos, trumpets, and coordinates that way? Or is it going to be more like a choreography where each entity in the system knows their part? And then based on the change in event, harmoniously they work together. Choreography? Yes. Awesome. Great job. Let's move on. So there's a lot of resources out there which talk about these things, about supporting large-scale distributed systems. So and you can refer to them later and strongly encourage it, but the main takeaways are these asynchronous non-blocking calls. The other one is separating your reads from your writes. Now, which, don't worry about terminology, command, query, responsibility separation, but essentially, separating your reads from your writes, and what we're talking about there is, once again, LMS, so many requests per minute. That's where the constant reads are happening. That's where your learners are. And in Studio, you have the course authors, and that's where they're actually changing the course content and whatever. But if you keep them separate, once again, that's where elasticity comes in. You can, whoops. So that's one of the big advantages of CQRS. And we'll give you examples of how we're actually using that. Now, bounded context, modularity and extensibility. Bounded context, let me give you an example, a concrete example of that. So if you had a bunch of these materials at your home, what's one way of organizing this? So let's say you decide to organize them by their technical concerns, by the materials that they're made of, steel, silver, plastic, wood, etc. Now, are you going to be able to find these things at your house? Or does it actually make sense to instead separate them by their business concerns, right? Kitchenware, hardware, currency, and so forth. Yeah, I have a drawer of my money and I have this and that, whatever. Now, that is actually a lot more logical, of course. And with bounded context, it allows you to think that way. And there's this thing called domain-driven design by Eric Evans, and he talks a little about how you work with your product and UX team to think along these lines. Now, unfortunately, edx-platform is currently organized by their technical concerns. There's a saying that if you regret the decisions that you made, that means you're successful. And, well, we're successful. So, yes, we decided to organize our code base by, what depends on Django versus, where are your templates located, and so forth. But now come with me. What could the future look like? If the future instead looks something like this, more aligned to also what our organizational structure is going to be, right? So it's a lot more clear. You have groups and users and progress and so forth. It's going to make onboarding easier for our own developers as well as the open source community. And not only that, it will allow us to think about what's called integration at the UI layer. So, for instance, we don't have to have LMS and Studio as first-class components per se, but LMS can choose which of the views that it needs from grades or progress or so forth, and Studio can choose it as well. And it will also allow us to, when we want to, if, for instance, progress is its own component, if we then, it's isolated and it's modularized, we can actually then pull it out of the repo and make its own first-class repo as well. So this is a direction that will allow us to get where we want to in terms of taming our monolith. And these are conversations that we're having within edX that I wanted to share with you guys. So what are some examples? I want some recent examples of how we're actually achieving these principles. There's a bunch of things that we've worked on recently. The two that I want to talk about today are block transformers and grades. You guys may not have heard of block transformers, so let me just give a quick rundown. But essentially, block transformers so our course structure, right, is a recursive hierarchical composition of xBlocks, as a lot of you may know. And those can become very big. MIT has a course where there's 4,332 blocks all in one course. And it's, it varies by course how many blocks they've chosen to have. But as you can see, if you're scaling, you have 4,000 courses and some of them with their own 4,000 blocks within the course and so forth. It is something that we want to make sure when a learner asks for a particular course, we can return it to them quickly. Well, once again, let's think about what we talked about, separating reads from writes. So block transformers is a mechanism by which we have separated these phases. We call it the collect phase and the read phase. Let the collect phase do all the expensive operations. Let it do the tree traversals. And let it do all the instantiation of xBlocks and getting it out from Mongo and do all the logic with inheritance, field inheritance, and all the things that are actually currently costly in xBlocks. And let's also denormalize the data, meaning if you have fields that are up in the hierarchy, right? Let's denormalize it so that if I only need a particular field from a lower part in the hierarchy, I can just go and access it. I don't need to go and do all the traversal at the time of reading it. So that's what the collect phase and separating the collect phase and read phase allows us to do. And the read phase, well, all of that heavy-duty lifting has already been done in the collect phase. So just go ahead and access that data. There might be user-specific and API-specific transformations that we need to do. Well, we can do that in the read phase. And that, in the read phase, is going to be synchronous, right? Because we're responding to an API request or a user response. But the collect phase, that can happen asynchronously. Whenever a course team changes the course, well, then let's send an event, let our choreography happen, and let the block transformers do their job. So here's another view of this information. So during the collect phase, we have the block transformer, the hierarchy, and it's a registry of transformers. It's extensible. So people can go ahead and register whatever the transformers they want, and automatically the system will run those transformers for you and convert that tree and add more data, whatever it needs to do in the collect phase. And then in the read phase, a user is making a request. So we take whatever data was collected, and then we go ahead and we transform it for that particular user. If that user does not have access to a particular subtree, well, just eliminate it and move on. So that's how access control can also be implemented in a scalable and in an extensible manner. Here's another concrete example of what I mean about denormalization. So let's take the start date transformer that's implemented in our platform. So in a start date transformer, what it's doing is it needs to provide access control based on this, when you actually get access to the block. So if the course says, oh, this course doesn't start until May, but then there might be other blocks later in the hierarchy that say, oh, actually, for this one, it's okay if it starts in April. Another one, no, actually, don't even let it be available until August, and so forth. So let's take a look at the bottom two here. And what happens is that then when the transformer is run in the collect phase, it actually denormalizes all of this. And it takes it actually takes a maximum of all the dates from its ancestors, and then it computes. So here, even though the descendant said it didn't start till March, actually the ancestor said May, and so that actually stores it as May. So then when I read and I want to figure out, oh, does the user have access to a particular block? I don't need to do all that traversal, right? I just go ahead and get what collected data was there. Now, don't worry about this stuff, but basically we also support DAGs, so that different nodes can have multiple parents. And so anyway, I can tell you guys more about that. But awesome stuff, right? So another example I want to share with you guys is the work that we did with grades. And for grades, thanks. So for grades, the main takeaway I want you guys to get out of this is our extensive use of asynchronous processing. And what we're doing now with grades, up till now, edx-platform didn't actually store a user's grade, but that didn't allow us to do all the things that we wanted to do in terms of showing progress quickly and things like that, and grade reports are taking very long to run and so forth. Well, we heard that issue, and now we're definitely addressing it. And what we're doing is, so whenever a learner submits a problem, we want to update their grade. Now, we don't want to, once again, responsiveness is such an important criteria for us. We don't want to take the time to recompute the grade before responding to the user. So what do? Fire a task and let the grades asynchronous task do its choreography job or whatever and compute it asynchronously. One other advantage of that is that if computing that grade failed, well, it's a separate task. Let it retry. What if it keeps failing because there's a bug in our code? Well, let's store that in a separate queue, in a failed queue, so that when we actually fix the bug, we can retry at that time. So that resiliency is there, right? And so we're able to, we've implemented all of this in edX, and we've experimented with it, and it's working now, and we're trying to, and we're scaling it. So it's just rethinking about how things can be done in a message-driven and asynchronous manner allows us to, think about how the code base can work. And then we're also, separating our reads from our writes. So this is LMS, where there's a stream processing queue, continuously processing grades and updating grades as learners make changes. But then we could have a separate queue that can be done in a batch processing, meaning it doesn't happen as often that course teams change courses, and that could affect the grading policy. By keeping those things separate allows our DevOps, and operationally, we can scale them differently. So you can see there's a lot going on here in action. You have asynchronous message passing. You see the resiliency in effect. You see how scalability and elasticity can happen. And finally, in terms of bounded context, we've done a similar thing where with grades, we've taken it out as a separate, within the monolith still, however, but it's now its own first-class citizen within the monolith. The other thing I want to talk to you about is all of these things that we're discovering, all of the things that we're learning about. We want to share that with others, with the community, as well as include the community in some of these best practices. the things that and of course we have OAPs that you guys must have heard of. There's going to be PRs within our documentation folders, and of course there's always Slack. The next things that we're going to touch upon are thinking about tests. Now, if you have a code base that's been around for this many years, and as you can see, the edx-platform code base perhaps has aged a little bit very quickly because, well, we're just working on awesome stuff, then the tests themselves have also not really evolved in the way that we would perhaps like. There are way too many unit tests, integration tests, and acceptance tests, and end-to-end tests. And so what exactly are we going to do with the tests? What are the best practices? So we need to address that. And we have a working group that's talking about this, and we'll talk about it. We're going to document this. And we want, if you have any input on this, definitely join us in that discussion. Once that best practice is in place, we can then actually start using them. Code structure we talked about a little bit in terms of bounded context. We want to codify this in terms of putting it in a document in the repo so everyone's on the same page. And finally, extensibility. Let's talk about this in the birds of feather. I want to get a lot more input from the community on this. Like, what are your biggest pain points? What are you thinking about in terms of extensibility? The thoughts that we have currently are, for instance, xBlocks to date had to be Django-independent. That means you could have a xBlock that can run in any runtime, whether or not it was Django or not. But we've learned from your feedback as well as ourselves that actually that's not a requirement that's necessary, and therefore let xBlocks use Django. Let xBlocks be their first class, their own bounded context. Be isolated. Don't be dependent on the edX platform. If you need something, then don't necessarily require that the platform's runtime gets updated. And so let xBlocks depend on Django is a best practice that we want to then put out there. If you need your own way of doing settings, if you need to be able to integrate with your own internationalization thing, whatever it is, there's a lot that you can do by thinking about xBlocks as its own independent thing. So that's one best practice. Pluggable frameworks, we are already using that within edx-platform, but basically how you can have a registry of libraries without needing to update the platform. LTI and single sign-on and webhooks. So these are all examples that I'd love to talk with you guys. Finally, if you guys have any questions, how much time do I have? 5 minutes? Great. So I'm happy to take questions now, and thank you so much for listening. Yes.
Sort of the timeline for this. How long has this been going on, and what's the future going to be?
Yes. So since December of 2011, things have continued to evolve. Over time, of course, we've always made changes iteratively. In terms of the asynchronous and the message-driven things, like we have extensively built libraries and utilities for this. So since we started on the grades project, that has happened. So that was end of last summer till now. In terms of the bounded context and discussions on that, we have a working group right now talking about the taming of the monolith. And like I said, we're at a point right now where we're talking about best practices. We're all aligned together in terms of, yes, we want to do this. And so now we're taking it from there. And that's why, I welcome everyone to communicate. Our discussions, our meeting notes, they're all out on our wiki, which are all in a public, publicly available. And then other things like extensibility, that's something where, yes, we have some REST APIs, but I mean, there's, and of course we've had xBlocks as a way of doing extensibility, but I think what we're hearing from the community in terms of their requirements for JavaScript or, other things like that, we're at a point where I would say that we're more in a discovery phase. So, any other questions? Yes.
Hello. No, thank you. Hello, I'm pretty used to distributed system breaking, and normally they break around the queue when it's rigid and doesn't want to forget stuff. If you make the resilience choice, when your system will break, it will break dramatically with a sigmoid, meaning that it will come as if there is no problem, then something will come for the 1% if you're sorting the time, and then it will break. Do you really want to make a rigid queue for the messages?
Yeah, so that's definitely something that we have experienced, and so that's how we've addressed it by having a fail queue. So if you have an asynchronous queue, right, which is receiving all these messages, then if there is any failure in the system, it automatically retries. And if there, like I said, even if automatically retrying doesn't address the problem because there's actually a bug in the system or some other external issue, then it allows us to queue it until later for later processing. And we've created automatic management commands and things like that to be able to address those issues. Yes, Regis.
Thanks. Thanks for your talk. I'm a big fan of the decoupling of the modules, the coupling of the xBlock and Django much less. But yeah, anyway, so...
Well, let's talk about it.
Yeah, we'll talk about it later, yeah. My question is about the decoupling of the modules. Where are you going to start? How are you going to do it? And do you consider that the community can help doing this?
Thank you for asking that question. And yeah, so what our current thoughts are to attack it from breadth first, so that if you're in a city or you guys know the analogy, right? Where broken windows, and as long as you have broken windows, there's going to be more broken windows, and I mean, if you fix one, if someone sees it, there's going to be more. And so our strategy is to actually attack it breadth first. We want to first actually at the top level organize the monolith in a way that it's actually in terms of what I showed earlier, in terms of at least what the bounded contexts are within it. So basically, you have a big ball of mud. Let's make chunks of smaller muds, okay? And then once you do that, it will at least allow, it should be a little bit more welcoming. And then over time, we tackle the small muds if necessary. We don't need to, like if you have a pile of mud, but it's a component that is never touched or used, then let it just be. Embrace it and move on. Let's move fast and let's create more features. So we're not here to deep clean. Right? We're here to just sort of really do what is necessary so we can work faster and the community can understand the system and so forth. Did that answer your question? You had another part.
Versions. How many versions it will take? How many versions will it take on the...
Oh yeah, you also asked about the community, sorry.
No, I was hoping you would give me a specific name for a module that you would start to...
Well, so grades. So grades is one example that we did this with. And Andy's team actually worked on the course outline recently, and that also, they basically moved that into a separate module. Once again, we're not talking about moving outside the repo at this time, but it's within the repo. Now, our platform team also is working on looking at the module store, and it's interesting because we actually experimented with, let's just take that module store out of that repo, but we ran into a lot of tight coupling and so forth. It actually acknowledged and validated our approach, which is just taking things out is going to take a really long time, and it may not be worth it. So right now what we're doing is we're just going to leave it there, but let it make it isolated, fix all of the interdependencies that are circular dependencies, whatever are in there, but within the same repo. So that's the approach that we're currently taking. And then after that, maybe we'll see about removing it out. So those three are great examples of recent changes that we've been doing for the last 6 months. And then in terms of how can the open source community help, I think if you are considering a PR and making functionality change, a feature change, if it's within the repo, if it's something that once these best practices are written, how should tests be? How should the code structure be? If you then consider, hey, let's do it the way that it should be now that we're wiser, that would be awesome. So that, basically let's do this as a community. That's what I would say. And then in terms of extensibility and all new repos that are created, new xBlocks that are created, if they follow this concept, that would be great. Any other questions? Okay, we're out of time anyway, so okay, sounds good. Thanks everybody, thank you very much.